This video talks about solving systems of linear equalities, and we're going to do that by graphing. These notes are a little bit longer, so I'm going to do basically every other problem for you and then talk about the ones that I'm not doing. If you are taking notes from the video, you can pause this at any time and finish the problems that we're not doing together on the video. So when we are graphing these, this first page is a review from Algebra 1. There's a couple of things that we need to remember. If you're graphing an inequality that's a less than or a greater than, you're going to use open circles and a dashed line. If you're using anything that is less than or equal to or greater than or equal to, you're going to use a solid line and closed dots. I've put a key up here on the top of the page that you can use to refer to as we go through these problems. So let's look at example 1. Example 1, this equation is in slope-intercept form. So in slope-intercept form, we need to identify the slope, or the m, which would be 3/4, and we need to identify the y-intercept, which would be 0, -2. Now before I start plotting anything, I need to look and see. This is a greater than. Greater than is going to have open circles and a dashed line. So I'm going to start by making an open circle at -2, and then I'm going to use my slope to find more points. So I'm going to go up 3 and right 4. I could do that again, up 3 and right 4. Oops, that one got a little off. Okay, I could also go down and to the left. That would work just as well. Now that I've got a series of points, I'm going to connect them with a dashed line. Now, that's the first half of the problem. The second half of the problem is to figure out which side to shade. We need to shade the true side of the graph. To decide which side is true, we're going to pick a point and test it. If that point works, we know that point is located on the true side, and we'll shade that side. If that point does not work, we know that point is located on the false side, and we need to shade the other side. So the test point I am always going to use, unless my line goes through it, is the point 0, 0. So I'm going to plug in 0 for y, and I'm going to plug in 0 for x. When I simplify that, I get 0 is greater than -2. And then I ask myself, is that true? And the answer is yes. So I look at my graph. 0, 0 is located right there. That means that that side of the graph has to be the true side because 0, 0 was true. So now I'm going to shade the true side, and I'm going to shade everything over here. If I look at example 2, that was also in slope-intercept form. My slope, which is the m, is -2. To graph it, I need to think of it as -2/1. My y-intercept is 0, 4. So I've started by plotting the y-intercept and then used the slope to find more points. Then it was time to test it. I used the point 0, 0. When I plug in 0 for x and 0 for y, it simplifies to 0 is less than 4. That is a true statement. Well, 0, 0 is right here on this side of the graph. Because that point is true, that must be the true side of the graph, and that's what I'm going to shade. Number 3. We did a lot with number 3 when we were doing the first test. Any line that says y equals is a horizontal line. So this is going to be a horizontal line at y equals -3. I graphed this one as a solid line because it's greater than or equal to. Notice example 4 over here is a dashed line because it's less than. All right, now I need to test it. 0, 0 is not on my line, so I'm going to plug in 0 for x, which there is none, and 0 for y. And when I do that, I get 0 is greater than -3. That is true. 0, 0 is located right there, so 0, 0 must be located on the true side of the graph, and I'm going to shade the true side. Example 4. On this one, it's not y equals, it's x equals. So instead of a horizontal line, I graphed a vertical line, and I graphed it at +4. And it was dashes because it was less than. Then I tried a test point of 0, 0. When I plugged it in, I got 0 is less than 4. 0 is less than 4, so I knew the point 0, 0 was located on the true side of my graph, and so I was going to shade on that side. Don't worry, they're not all true. Let's see what happens now. Equation 5 is in standard form, and in standard form, you can graph it many different ways, but the way we're going to graph it is by finding the x and y intercepts. The x-intercept is when y equals 0, so it's going to be some number, comma 0. The y-intercept, on the other hand, is when x equals 0, so our ordered pair is going to be 0 some number. So on number 5, when I find the x-intercept, I'm going to plug in 0 for y. When I do that, the y cancels out, and I'm left with 2x, and yes, I'm going to put an equal sign equals negative 6. When I divide by 2, x equals negative 3. Oops, getting ahead of myself. So my x-intercept is the point negative 3, 0. My y-intercept, on the other hand, is when x equals 0. So when I plug in 0 for x, it cancels out, and I'm left with negative 3y equals negative 6. So y equals 2. So my y-intercept is 0, 2. Now this math that I'm doing is not very hard, and if you can do it in your head, that's great. I don't expect you to show all your work, but I'm writing it down so you can figure it out if you needed help. Before I plot the points, I need to look at the inequality. It's a less than symbol. If it was less than or equal to, it'd be a solid line or closed points, but it's not, so it's going to be an open circle with dashed lines. So I'm going to make a point at negative 3, 0 and a point at 2, 0. Then I'm going to use a dashed line to connect the two points and create my line. Now I need to pick a test point. 0, 0 is not on the graph, and 0, 0 is the easiest test point to use. So when I plug in 0 for both x and y, I'm left with 0 on the left and negative 6 on the right. Well, 0 is not smaller than negative 6. So this point 0, 0 now, we know, is on the false side of the graph. And we don't want to shade the false side, we want to shade the true side. So since 0, 0 is on the false side, the true side must be over here, and that's the one I'm going to shade. Let's look at number 6. On number 6, it's also in standard form. So I found the x-intercept by plugging in 0 for y. So I get 4x equals 8, so x is 2. That gives me the x-intercept of 2, 0. Doing the same thing for the y-intercept. For the y-intercept, now x is 0, and I get negative y equals 8, so positive y must equal negative 8. So my y-intercept is 0, negative 8. Because this is a greater than or equal to and not a greater than, it's going to have a solid line. So I'll plot the 2 points and connect the dots. Then I'm going to do a test point. When I plug in 0, 0, I get that 0 is greater than 8. That is a false statement. So 0, 0 is over here. That means that that's the false side of my equation, and so I'm going to shade the other side so that I know is the true side. Okay. Now this first example has been done for you, and then we're going to do one together. So as I'm going through here, I can see there's 3 equations, so I'm going to graph 3 lines. The first one is in standard form, so I found both the x-intercept and the y-intercept. Before I plotted it, I saw that it was a less than symbol. That meant that I was going to have open circles at those 2 intercepts. I then connected those open circles with a dashed line. Then I used the test point of 0, 0. When I used the test point of 0, 0 and plugged it in, I got 0 was less than 1. That is a true statement. So that is why I shaded towards the center and towards the y-intercept. Well, actually, I didn't shade quite yet. I just put arrows in there to indicate which direction I will shade, because when you're solving a system of inequalities, you're only shading where all of the inequalities are true, not each individual one. Then I went to do x is greater than or equal to 0. That is going to be a vertical line right there on the axis. I can't use 0, 0 as a test point anymore because 0, 0 is on my line. So I use the test point of 1, 1. When I put in a 1 for x, I get 1 is greater than 0. That's a true statement, so I'm going to look at my graph, and 1, 1 is to the right of my red line. So I know that since 1, 1 is true, I need to shade on the true side, which would be to the right. That's why I put the red arrows pointing right. I did the same thing for y is less than or equal to 0, but in this case, that is going to be the green line that is horizontal when it's y equals something. And when I did the test point, I could not use 0, 0 again, so I needed to use 1, 1, and I got that that was false. 1 is not less than 0, so I shaded away from the point 1, 1, and I pointed down. Now, to be able to do my final shading, is what you see in yellow highlight, that had to be done, and I shaded that quadrant only because all 3 graphs were true in that one area. All right, let's try this now together on example 2. So in example 2, this first equation, it's almost in slope-intercept form, but not quite. So if it makes you feel better, you can rewrite this as y is greater than or equal to negative 2x plus 16. So if you were going to graph that, you would have needed to identify the slope, which we know is negative 2, and to graph it as negative 2 over 1, and the y-intercept is 0, 16. Now, as I'm looking actually at all 3 of these, they're either less than or equal to or greater than or equal to, which means all of these are going to be closed in circles and solid lines. So first I'm going to plot the y-intercept at 0, 16, and then I'm going to use my slope, negative 2 over 1, to go down and to the right. Now that I have my points, I'm going to connect the dots, and there's my line. Let's figure out the shading. So I'm going to test a point. So I have 0 is greater than 2 times 0 is 0, so 0 is greater than 16. That's false. So I'm going to shade away from the center. All right, let's try this again on the second line. On the second line, if I'm going to rewrite this so it's technically in slope-intercept form, I get y equals negative x plus 16. So on the second line, my slope is negative 1. So as a fraction, it's negative 1 over 1. The y-intercept, oh, it's the same thing. It's 0, 16. So I'm going to make a point at 0, 16, which I already have, but this time I'm going to go down into the right one, and my line will now go along with these dots. So I'll connect those points. Now I got to do a test point. So I'm going to do 0, 0 again. So when I put in 0, 0, I get 0 is less than or equal to 16. That is true. So now I want to shade to the center. So now I know on this graph that I'm going to shade in between the blue and the green lines. Last but not least, I need to graph the line y is greater than or equal to 6. Well, anything that's y equals is a horizontal line. So I'm going to draw a horizontal line at 6. Now I need to do a test point. Well, I'm going to test it at 0, 0. And at 0, 0, I get 0 is greater than 6. That is false, so I need to shade away from the center, and I need to shade up. So if I shade above the red line, to the right of the blue and the left of the green, the area that I'd be shading is this triangle right in here. So what does that mean? That means I can pick any point in that shaded area and it will be a solution to that system. So instead of having just one answer like we normally do when there's an equal sign, now we have a multitude of answers. There's a range. Anything in that range will work. All right, let's see what happened on number 3. On number 3, that first equation is in standard form. So I had to find the x-intercept and the y-intercept. The x-intercept is when y equals 0, so I solved and got x equals 7. The y-intercept is when x equals 0, so I solved and got y equals 14. Then I plotted those 2 points and connected the dots. Did the same thing for equation 2. Oh, got to do the test. So I plugged in 0, 0. I got 0 is less than 14. That's true. Shade towards the center. Then I did the same thing for equation 2. The x-intercept turns out to be 10. The y-intercept turns out to be 5. I plotted those 2 points and connected the dots. Then I plugged in a test point. And with the test point, I plugged in 0, 0 because it wasn't on the axis, and I got that 0 is less than 10. That's true. So I shaded towards the axis. All right, then I graphed x is greater than or equal to 0. That is a vertical red line running up and down right there on the axis. This time I could not use the test point of 0, 0 because it was on my line, and so I used the test point of 1, 1. When I used that, I got 1 is greater than 0. That is correct. 1, 1 is to the right of my red line, and so I'm shading to the right. Did the same thing finally for y is greater than or equal to 0, and this time it was a horizontal line. It's the purple line that I have drawn on my graph. Once I do the test point, I can't do 0, 0 because it's on my line, and so I did 1, 1. And so when I did 1, 1, it turned out to be true because 1 is greater than 0, and 1, 1 is located above my line, so I'm shading up. So once I have all 4 constrictions in there, I need to shade to the right of the red, above the purple, to the left of the blue, and to the left of the green. And I create that 4-sided figure in there, which is a quadrilateral, and I shade all the points that are inside my quadrilateral. That means any point that's in my quadrilateral will be a true point and work for my system of inequalities. All right, let's do the last one together, the word problem. So Malcolm can earn money mowing lawns and walking dogs. So our goal is to figure out a system of inequalities that will allow us to figure out how to meet all the different constraints that Malcolm has. Well, there's 2 things that Malcolm can do. He can walk the dog and mow the lawn. Since mowing the lawn is listed first, I'm going to say x equals the number of hours mowing. Walking the dog is second, so I'm going to say y equals the number of hours dog walking. Whoops. Now I need to write a system of inequalities that meet all these constraints. So let's read the first sentence. Malcolm earns $20 per hour mowing lawns and $10 walking dogs. So if we're trying to figure out how much money Malcolm is making, we're going to take $20 times however many hours he mows and $10 times how many hours he walked the dog and add those together. So if I take 20 times the hours of mowing plus 10 times the hours of dog walking, okay, we can figure out how much money he's making. Well, his goal is to make at least $200. At least $200 means it needs to be $200 or more. So this value over here has to be greater than 200. It could also be equal to 200. So I put that it's greater than or equal to. Then it says that Malcolm can work a maximum of 20 hours. So if I take the hours of mowing plus the hours of dog walking, that total has to be 20 hours or less. So this number has to be less than or equal to 20. We also have to keep walking the dog. The dog needs to be walked a minimum of 5 hours per week. If we look at my variables, y represents the number of dog walking hours, so I need to say y has to be greater or equal to 5, because the dog needs to be walked at least 5 hours, if not more. Now that I've got my system, now I can go ahead and try and graph it on my graph. So for the first equation, okay, it's in standard form, so I need to find the x and y intercept. So to find the x-intercept, I'm going to plug in 0 for y, so I get 20x equals 200. Divide by 20, x is going to equal 10. For my y-intercept, I get 10y equals 200. I divide by 10, and y equals 20. So here now are my two ordered pairs. All right, so, and all of these are less than or equal to or greater than or equal to, so solid dots and solid lines. So I'm going to have a point at 10, 0, which is right here. And 20 is not really on my graph, but if this is 17, that'd be 18, 19, so it's right there. We can just make it work. And then I'm going to connect the 2 points. Now I want to test. What's going to happen when I need to shade that? Well, if I plug in 0 to both of those, I get 0 is greater than 200. That is false, so I want to shade away from the center, so I'm going to shade up. Let's see what happens on the next graph. On the next graph, it's in standard form as well, so I need to find the x-intercept and the y-intercept. So the x-intercept is when y goes away, so I get x equals 20. The y-intercept is when x goes away, so I get y equals 20. So my ordered pair is 0, 20. If I go to graph that, I've already done 0, 20. That's no big deal. But 20, 0, that's not on my graph either. We're just going to fake it. 13, 14, 15, 16, 17, 18, 19, 20. About here looks good. Connect my 2 points. All right, now when I go to test it, 0 plus 0 is 0, so I get 0 is less than or equal to 20. Definitely. So I need to shade towards the center because 0, 0 is my center. All right, the last line, it's y is greater than or equal to 5. That's a horizontal line, so I'm going to draw a horizontal line right in here. And now I need to test it. I can use 0, 0 because it's not on the line. Is 0 greater than or equal to 5? No way. So 0, 0 is below the line, so I need to shade above. So now that I shade above, I know the area that I'm going to shade is right in here. That means any point in that region is going to be true. So now the next thing it asks, it says pick a point in the shaded area that's a solution. So I'm going to go over here and let's pick a point. How about this one? This point is the point 97. Now you could pick any point in the yellow, so it's very possible that 10 people could pick 10 different points and you would all be right as long as it's in that yellow shaded region. Okay, now we need to write out what that means in words. Well, we can use our variables that we declared to help us out. X is mowing and Y is dog walking. So in this situation, Malcolm could mow for 9 hours and dog walk, whoops, can't spell walk today, take 2, dog walk for 7. Now, if you were taking the quiz, before you finish that, let's make sure that makes sense. We know that Malcolm has to work no more than 20 hours. Well, 9 plus 7 is 16. That's less than 20. It works. We also know the dog has to be walked for more than 5 hours. This gives us 7. That makes sense. So our answer makes sense and we know we're on the right track. That's it for this lesson.